Hi, welcome to my video again. In this video, I will show you how to simulate a buck converter. And in this simulation, we will show you the effect of switching frequency and pulse width modulation. We will start with a simple buck converter with a resistive load, and then we will modify the buck converter. We will add an inductor. We will start increasing the value of the inductor to see this effect on the output voltage and the output current. And then we go back again and we will switch we will change the switching frequency, and we will see that effect of that frequency on the output voltage and the output current while keeping or fixing the inductor value. At the end of the simulation, we will also see the effect of adding a capacitor when we have a fixed frequency and a fixed inductor value, and see the effect of that change on the output voltage and output current. And let's start with describing the circuit. As you can see here, we have a DC power supply, and I have chosen a 100 volt, and there is a pulse generator, and on that menu you will see I can select the frequency of the pulse generator is the period, which is 0.05, which means that it's 20 hertz, and I have chosen the pulse width is 50% at this stage. We're gonna come back again and see what's gonna be the effect of changing pulse width as well on the output performance. And I have used a single IGBT, and then here is just oscilloscopes, and these blocks are to calculate the mean values or the average values, and these are the RMS. I have inserted a current sensor to measure the supply current, whether it's for mean value or RMS value. Also, this is the resistor, which we will start with analyzing only just a load with a resistive load, and that's only 5 ohm. And also I've inserted a current sensor to measure the current and the output resistor and the output load, and also I can see I can measure the average value here, and also the RMS value again. The output voltage I can measure it by this device, which is the mean value, which will tell us the average value also, and the current, the RMS value, again the RMS value of the voltage output will be shown here. Now this oscilloscope is just to show the waveforms of the output voltage and the output current, as you can see here. And let's start and see what's gonna go on in that simulation. Alright, that was quick. Again, let's see. In that screen we can see this yellow, the upper part, which shows the voltage, and the maximum voltage is 100 volt and the minimum is 0, and the average voltage is gonna be 50. And this is because it's 50% duty cycle, and the current, the maximum, the peak value is 20 amps, and the average is 10 amps, and that is because we have a 5 ohm resistor. So if we divide the output voltage on the resistance, we will get the average current. So as we can see here, this is the average value of the voltage, that's 50, and the average value of the current, that's 10, and this is the RMS of the output voltage with 70.7 voltage, and the output RMS current is 14.14, and that goes well with the equations which we have developed earlier in our lectures. As compared to the theoretical calculation, it goes well actually in what we have achieved so far. Now let's see the effect of changing the pulse width. So we will increase it a bit, 75%, and see that effect on the output voltage and current. Alright, as we can see here, the output voltage has increased up to 75, and the average current as well has increased accordingly up to 15 amps, and the RMS values has increased. If you look at the waveforms will not, as a maximum, in what will be, it's not going to be changing, because only the value of the average will be changing. The duration or the width of the pulse has changed, of course, because we have increased the pulse width of the pulse generator is up to 75%. That's shown here. And let's see if we change the frequency, what's going to happen. So the frequency will start increasing from 20 to 200. Of course, I have to change the frequency of the block to calculate the mean value here. So in order to calculate the average across the 1/200 frequency. So let's start again and see what's going on. Yes. So there's not change in the average value or the RMS values of the currents or the voltages, and that's because we are dealing with only a pure resistive load. Now let's see if we change, what happened if we change the circuit. We will insert now an inductor and see the effect of the inductor on the circuit.